Hello everyone, this is Chandan and you are watching the learning field. Okay, so in this video, this is the lecture 12 of LPP linear programming problem. In the lecture 11, we are just discuss the row minimum method and column minimum method of the transportation problem. Okay, so we are discussing the transportation problem and we are studying the matrix minima method in the last lecture, but due to some technical issue we are not complete the class or no session. Okay, so this is the session especially for matrix minima method. Okay, so in the row minima method what we are doing, we first find the minimum of we take first row suppose and then find the minimum element from the first row and then allocate this cell of the demands and to see the demands and availability from the origin. Okay, and in the column minimum method we first take one column, suppose this is the first column, then we see these elements and take the minimum element, minimum most element, that is minimum most cost, and allocate their first what allocate to their first minimum quantity of the demands and the from the demands of the destinations and the availability of stocks. Okay, so just a minute, I'm forgetting to write the what these are 14 unit, 16 unit and 5 unit, 6 unit, 10 unit, 15 unit and 4 unit. So first we have checked that this transportation problem is a balanced transportation problem or not. Okay, so if summation ai equal to summation bj, then the transportation problem is a balanced transportation problem, and if we add this sum, then 6 plus 10 16 plus 15 31 and 4 35, and this side gives 30 plus 35, so 35 equal to 35. So the transportation problem is a balanced transportation problem. Okay, now here in case of matrix minima method, we find the minimum most element from the all elements of the matrix. Okay, that is we find the minimum cost from the all over the matrix. Okay, so see here there are the minimum cost is this one. Okay, so we first allocate in this cell. Okay, so this is the cell number x13. Okay, so x13 equal to minimum of what, minimum of total stock available in the origin O1 and the demands of O3. So this is equal to 14 and 15, so this is equal to 14. Okay, so here we allocate number 14. Therefore the origin 1 is exhausted. Okay, so origin 1 exhausted, that means this goes cancel, and here 1 unit of demands is remaining now for D3. Okay, so this is the first step. Now we see the second in the minimum most element in the matrix, that is minimum cost. Okay, so here we see this is the second minimum cost, that is 2. Okay, so we allocate this cell and this is the cell number x23. Okay, so x23 equal to minimum of what, minimum of total availability from the origin O2 is 16 and availability of unit demand for the destination D3 is 1 unit. Therefore this is equal to 16 and 1, this is equal to 1. Okay, so we here allocate 1. Therefore the demands for the D3 destination is exhausted. Okay, and now here the remaining availability from the origin O2 is for 15 unit. Okay, so this is now remaining 15 unit. Okay, now see here there is another same cost. Okay, so this is the another same cost too. So you can take this cost first or this cost first, this cell first, there is no doubt. Okay, so you can take any one of this firstly. Okay, so there is no issue. Okay, so in this cell we take the minimum of what, minimum of this 5 and this 4. So this is the cell number x34 equal to minimum of what, minimum of total availability of the origin O3 is 5 and total demand for the destination D4 is 4. So this is equal to 4. So we write here 4. Okay, so the demand for the destination D4 is exhausted. Okay, and now here the availability from the origin O1 is remaining 1 unit. Okay, so this is case. Now we find the next minimum element in the matrix. Okay, so next minimum element in the matrix is this 3. Okay, so we allocate here and this is the variable what, x32. Okay, so x32 equal to minimum of what, x32 equal to minimum of 1 and 10. Okay, so x32 equal to minimum of 1 and 10, so this is equal to 1. Okay, so we allocate here 1, and now the availability of the origin O3 is exhausted, so this is cancelled out, and this is remaining demand for the destination D2 is remaining 9 unit. Okay, so this is the case. Now we find the next minimum element. Okay, so the next minimum element is what, I think this is exhausted, so this is the next minimum element is this 8. Okay, so we allocate in this cell. Okay, so this is the cell number what, x21. So x21 equal to minimum of what, demand of the destination D1 is 6 unit, and available for the origin from the origin O2 is 15 units. So this is 6 and 15, so this is equal to 6 units, so we allocate here 6 unit. And now the demand for the demand for the destination D1 is exhausted. Now we remaining 9 unit here, and one cell only the remaining, therefore we allocate here the 9 unit. Okay, so that means what, x22 this is equal to minimum of what, 9 and this 9, so minimum of 9 and 9, so this is equal to 9, therefore this is the total allocation. Okay, therefore the optimal solution is what, the initial basic feasible solution is equal to what, x, these are the solutions, x1 3 equal to 14, x2 3 this is equal to 1, x3 4 this is equal to 4, x3 2 this is equal to 1, x2 1 this is equal to 6, and x2 2 this is equal to 9. Okay, and the objective is the transportation cost, so therefore the transportation cost that is the value of the objective function, this is equal to what, this is equal to 14 into 1. Okay, so 14 into 1 plus 8 into 6 plus 9 into 9 plus 2 into 1, the allocation and corresponding what, cost. Okay, 2 into 1 plus, you all know that, 3 into 1 plus 4 into 2. Okay, so this is equal to, I think, 14 plus 8 6 is 48 plus 9 9 is 81 plus this is plus 2 1 is 2 plus 3 1 is 3 plus 4 2 is 8. Okay, so this is, I think, 62 plus 81, 143, 145, 148 and 156, I think, yes, 156 unit. Okay, so this is the required initial basic feasible solution, and this is the method. Okay, this method is a very easy method, but these methods are very important because in the year 2022, I think, there is a questions in GATE 2022 from the what, northwest corner method. Okay, so these 4 methods, that is, one is northwest corner method, the 4 methods we already discussed. One is northwest corner method, second one is row minima method, third one is column minima method, and fourth one is matrix minima method. Okay, so we already discussed these 4 methods. Okay, these methods are very important. Okay, because there is a questions asked in GATE 2022. Okay, so you can think the you can see the importance of these methods. Okay, LPP series, and the solution is already available in the channel, so you can watch it. Okay, so now the next lecture will be on the most important method, which is Vogel approximation. Okay, Vogel approximation method, or Vogel method simply, or the short form is VAM. Okay, so in the next lecture we discuss this method, Vogel approximation method. Okay, so this is the content for the video. If the content is helpful, then please give a like to this video, share with your friends, and subscribe the channel. Okay, thank you, and sorry for the inconvenience, because in the last lecture there is some technical issue occurs during the live lectures. Okay, so sorry for that. सो मिलते हैं अगला वीडियो में। थैंक यू, टेक केयर।